Welcome to Study Loop.
41.16, we want to calculate the number density of oxygen gas at 0 degrees Celsius and 1 atmosphere of pressure. We want to calculate the number density of electrons in conduction electrons in copper. We want to find the ratio of those two number densities. And then we want to find the average distance between particles in both cases, and the particles will be oxygen molecules in the one case and electrons in the other. So here, if we start with the ideal gas law, we have PV equals NKT. Then N over V, which will be our N sub O, equals P over KT. And this is 2.7 times 10 to the 25th per cubic meter. B, now for copper and its conduction electrons, we have this is just combining the equations for 41-2 through 4. You can find back in the chapter. And so we have the density of copper here, 8.96 times 10 to the third kilograms per cubic meter. We have the atomic weight of copper, 63.54. And then we have the mass of an electron, 1.67 times 10 to the negative 27th kilograms. So this is sort of the number of, sort of the number of copper atoms per cubic meter, basically, with the needing to then convert that to electrons. And so then we get 8.43 times 10 to the 28 inverse cubic meters. So now the ratio N over NO is 3.1 times 10 to the third. And now for D and E, just do them together. The average distance between particles is 1 over the cube root of the number density. You basically just assume that the distance is the edge length of a cube whose volume is equal to the volume each particle has on average. And so this is 3.3 nanometers for oxygen gas and 0.23 nanometers for the electrons in copper. So you can see there's a lot more. The electrons in copper are packed together quite a little bit more closely than the oxygen molecules in air are, which are already, they're pretty close together.